Our brains are marvelous organs, capable of processing vast amounts of information in a split second. However, despite their incredible abilities, they are not infallible. In fact, they often play tricks on us, presenting illusions that deceive our senses and perceptions. In this journey through the realm of brain illusions, we will explore some of the most common types, unravel their causes, and shed light on the fascinating mechanisms behind their formation. The causes of optical illusions vary depending on the specific illusion in question, but they generally occur due to the complex ways in which our brains interpret visual information. Here are some common reasons for optical illusions. Our brains often interpret 2D images in ways that imply depth or perspective that may not actually exist. This can lead to misperceptions of size, distance, or orientation. But how do these illusions arise? At the heart of many optical illusions lies the complex processing performed by the visual cortex, where neurons decipher incoming visual signals and construct our perception of the world. One key factor contributing to optical illusions is the brain's reliance on heuristics, mental shortcuts that simplify decision-making but can lead to errors in judgment. Variations in contrast, brightness, and color can trick our brains into perceiving shapes or patterns differently than they actually appear. Our brains are wired to recognize patterns and shapes, sometimes filling in missing information or organizing visual elements according to Gestalt principles such as proximity, similarity, and closure. Staring at a moving stimulus for an extended period can induce the illusion of a stationary stimulus moving in the opposite direction. For instance, following prolonged observation of a waterfall, nearby rocks might momentarily appear to ascend. This phenomenon occurs due to the prolonged exposure to specific visual stimuli, which can lead to adaptation or fatigue in our neural receptors, thereby altering our perception of subsequent stimuli. Some illusions exploit the differences in processing between the left and right hemispheres of the brain. For example, the spinning dancer illusion can be perceived as rotating clockwise or counterclockwise, depending on which hemisphere dominates the interpretation. Our expectations and the context in which we view an image can influence our perception of it. Consider the cafe wall illusion as an example. In this illusion, alternating rows of dark and light tiles are arranged in a manner that creates the impression of slanted lines, despite their parallel alignment. The brain's anticipation of uniformity and alignment in brickwork contributes to the illusion of slanted lines. Cognitive illusions arise from biases, heuristics, and other quirks of cognition that influence our decision-making processes. A typical example is the Wason selection task. You are shown a set of 4 cards placed on a table, each displaying a number on one side and a color on the other. The visible faces of the cards show 3, 8, blue, and red. Which card must you turn over to test the rule that if a card shows an even number on one face, then its opposite face is blue? The correct answer is to turn over the cards showing 8 and red. This is because if the 8 card is not blue, it violates the rule. Similarly, if the red card is even, it violates the rule. Our hearing can sometimes be deceived as well. These illusions manipulate how our brains interpret sound waves, resulting in perceptual phenomena that appear to contradict the laws of physics. One notable example is the Shepard tone, a sound that creates the illusion of perpetual ascent or descent in pitch, seemingly without ever reaching an endpoint. This auditory trick exploits our brain's difficulty in perceiving absolute pitch, leading to a continuous sensation of upward or downward movement. Tactile illusions manipulate the brain's interpretation of tactile stimuli, generating perceptual anomalies that challenge our understanding of haptic perception. One prominent example is the rubber hand illusion, a captivating phenomenon that demonstrates the brain's capacity to amalgamate sensory input to construct a cohesive body representation. It entails manipulating visual and tactile stimuli to evoke the sensation that an artificial hand is a genuine part of one's own body. Preparation involves the participant placing one of their hands out of sight while a rubber hand is positioned in front of them. Simultaneously stroking both the rubber hand and the subject's real hand with identical strokes and timing creates congruence between seeing the rubber hand being stroked and feeling the strokes on the real hand. This synchronization leads to the brain prioritizing visual input over tactile input over time. As the illusion develops, the subject often develops a profound sense of ownership over the rubber hand. To assess the strength of the illusion, researchers employ various methodologies. For instance, they may threaten the rubber hand with a tool while observing the subject's response. Despite the subject's rational understanding that the rubber hand is not their own, those experiencing a strong illusion may exhibit physiological responses such as increased sweating or heart rate when the rubber hand is threatened. Brain illusions unveil the complexities of perception and cognition, offering insights into the workings of the human mind. By studying these phenomena, researchers gain valuable knowledge with applications in psychology, neuroscience, and beyond. In this realm, the boundaries between reality and perception blur, showcasing the remarkable capabilities of the brain.